plenary. Can I check that Jing Su is present? Jing, are you?
Yeah.
Okay, thank you. So our closing, we have the honor of having Jing Su to give the closing plenary, and he'll be talking about automarking in language assessment, key considerations for best practice. Jing Su is head of propositions research at Cambridge University Press and Assessment. His research interests are in the application of cutting-edge AI technologies in language assessment and learning and the related validity issues. His latest research focuses on automarking of L2 English speaking and writing assessments. Jing is currently co-chair of the ILTA Automated Language Assessment Special Interest Group. He received his PhD in Applied Linguistics and Technology from Iowa State University with a focus on language assessment. Would you like to share your slides, Jing?
Yeah, thank you, Alina. Can you see my screen all right?
Yes.
Okay, so thank you for having me here. It's my first time participation in the ILTA SIG meeting, and I have seen really interesting talks about using large language models to either generating synthetic data or training an automarker to score writing written responses. So I work in the English research group at Cambridge. So my main work is involved in training, evaluating automarking system for linguist skill and Cambridge English qualifications. But I have to confess that I have very limited experience of using large language models to automatically assess writing and speaking, because there's some concerns about data security. So when we gather sensitive test data, test responses data, when we pipe the data through the open source third-party large language model, which is a black box, so we have concerns about data leak, etc. So all the automarking system developed in Cambridge are based on the traditional machine learning models. And also we don't use any synthetic data. We use real data from previous human marked exams to train the automarkers. So that formed the foundation of this talk. Just want to give you a quick update that this is based on a paper we just published on the Cambridge website. So if you Google the same title, you will find a white paper about this talk, but actually we are going to adding something new in addition to the paper. So let's just move on. So this is the structure of the presentation. I'm first going to talk about what is automarking and why we do it. And then the main part of this presentation is about the 12 fundamental principles of good practice about using automarking in language assessment, and which is also the backbone of the white paper we published. And the third part is about evaluating automarker accuracy. I'm going to briefly talk about different methodologies, because interestingly, I saw some evaluation method being mentioned in other talks, like in Burak and Ananda's talk about using Cohen's kappa or quadratic kappa. And from Mariana's talk, they are using interclass correlation and correlation. So we're going to talk about whether these methods are appropriate or not. All right, let's just move on. First, the definition of automarking. So it's an AI-based system, scoring system, and different ways to train an AI scoring system. It could be a ASR-based system, like in Merson's speaking test. There's a lot of repetition with a lot of tasks. So the scoring algorithms is mainly based on automated speech recognition. And also the regression-based system is mainly used in E-Rater and also Speech Rater. The ETS automarking system are mainly regression-based system, which are feature-based. And there are also like deep learning models, which is more like a neural network model, which is a black box, which has a really high general prediction accuracy. But the advantage of a deep neural network model is that it could generate a confidence score, which I'm going to talk about later. And also the automarking system are used to train to mark complex constructed responses, writing and speaking. And this is almost common knowledge. And we expect the automarker to predict the scores that the human examiners would give. And in some automarking system, the automarker may indicate confidence in score prediction. I can tell you I can tell you what my score prediction is, but I can also tell you how confident I am in my scoring. And also another important component in automarking is not only about score prediction, but also to flag unusual or aberrant responses, which is a big threat to automarking system, especially in high-stakes assessment context. All right, so benefit of automarking efficiency, I think Mariana talked about like having readers to spend like 5 or 10 minutes marking every email. So efficient and cost reduction is definitely a benefit of automarking. And marking consistency, I can talk for traditional machine learning-based automarker. Generally, it's consistent. When you feed the same data, it just produces the same score. But I'm not sure about large language models, because you can see that when you're prompting the same prompt into the large language models, it generates different content. From the scoring bit, I'm not so sure whether you send the same responses to the large language models, they'll give you the same score or not. I don't have any sort of research on that. And also, the automarking will increase accessibility to assessment, to mitigate examiner shortage, and help to increase the availability of on-demand testing, so you don't have to book a test anymore. And there's a potential for providing learning-oriented feedback. So you know that Cambridge has the Speak and Improve, Writing Improve system, which can help you to practice your speaking and writing, and also generate diagnostic feedback in terms of scores and also qualitative feedback as well. So, but scoring is the first step before generating feedback. Okay, and this is background information. How does the automarker look like? What is the general architecture? So usually you send a constructor response either in writing or speaking. There's a feature extraction process to extract construct relevant features. For example, speaking can have like speech rate, number of disfluencies, and also feature from ASR, automated speech recognition, how confident ASR is, and also lexical diversity, complexity, etc. So these are all features that can inform the scoring model. So the features are called the scoring features, and the scoring model will be picked on different features to make the best prediction of the human scores. And in some models, like deep learning models, it can also generate a confidence score telling you whether the score prediction is accurate, how likely the score prediction is accurate. And the additional component is aberrant response detection, like off-topic responses or speaking nonsensical language, or the organization it's very strange, or there are double attempts, 2 attempts. So there should be a separate component for aberrant response detection to prevent any gaming behaviors. Okay, so this example, a quick example of how human-machine hybrid marking looks like in Cambridge's auto-marked language tests. So on the left side is the test, and the part 1, part 2 responses are sent to the automarker. The automarker will give a score, and also there's a flagging system. So give you a confidence score, and also there's an aberrant response detector. So there are 2 scenarios, dichotomous scenarios. One is that one response is flagged for 2 different reasons. One is that the confidence is so low, the confidence score is below the threshold. So although the automarker gave the score, but they said, okay, the score is likely to be inaccurate. Or there's another case is that the flag for any aberrant behaviors, like it's not speaking English, or there's an impersonator speaker who is speaking on your behalf, or there are 2 different voices in the speaking test, or in the writing part. In the writing part, like the essay is totally off topic. It's not really addressing the bullet points in the test instruction. So if anything is flagged, then the response will be given to the human marker. The human marker score will be used instead of the automarker score. But in other cases, when automarker is confident, there's no flagging, so we can confidently release the automarker score to the candidates. So this is the flow chart. Oh, okay, now we're going to go into the 12 fundamental principles of good practice in automarking, and we have 3 different circles, 3 different layers. The green circle, in the green circle, is about automarker development and evaluation, and the orange circle is about how to use in a third-party automarker. It could be developed by yourself or using a third-party automarker. And the largest circle is about the impact of using automarking system to stakeholders. And you can see there are 12 principles addressing different areas, like for training data, scoring features, accuracy evaluation, etc. Okay, and I would like to mention that these 12 principles are not coming out of nowhere. So we consulted different standards about automarking practice. Like Xiaoming Shi had a paper published in Language Testing Journal back in 2010 to talk about a validation argument for automated scoring and feedback systems, which is very instrumental. I would say this is a groundbreaking piece of work, which is still influential. And also, in 2014, APA published the standards for educational psychological testing. They also mentioned how we can use the automated scores for general educational assessment in high-stakes context. And more recently, there's a guidelines for a technology-based assessment, talk about what are the training data should look like. For example, we should not train the automark with single marking data, etc. So all these sources help us to formulate the 12 principles. I'm now going to delve into the 12 principles. The first principle is about training data. The question is the training data representative of kind of characteristics. So when you train automarker, you need to think about whether the training data are representative of your target candidates in terms of ability levels, first language backgrounds, gender, and age groups. So an automarker trained on adult responses or spoken response is not really suitable for assessing young learners because ASL would be totally erroneous. And also, we would generally see that automarker performance is more accurate in the middle of the score band because there are more training data. Usually, they're more responsive in the middle of the score scale than the two edges, than two ends. So automarker tend to be more accurate in the middle than on the two ends. So if you want to sort of cancel this sort of observation, you need to top up the training data on the two ends of the score scale as well. So you need a balanced data set. But this is not really relevant to using a large language model because it's usually a few shots training. And then you don't know how the training data look like behind the scene. So I cannot comment on that. And also scoring features is usually when you train a model, you would think about what features are construct relevant. And so the question is, are the scoring features sufficient to capture the complex nature of language use? So I think one person had a question about whether pragmatic competence is captured by the automated scoring system. This is a really good question because this is high order skill. I would say most of the scoring features that we use right now are addressing surface language use like linguistic features like punctuation, fluency, vocabulary use, grammatical accuracy, complexity. So these are all about language, but actually from the social linguistic perspective, automarking is still quite limited in terms of assessing a person's, for example, interactional competence. So how we sort of pick on each other's language and co-construct a spoken discourse, this is quite limited right now. I don't think any scoring feature in the current automarking system can assess interactional competence, although we have a very strong sort of desire to assess interactional competence in the speaking assessment context. Okay, the third one is about accuracy evaluation. I won't spend too much time on that, but I will talk sort of open up the discussion in the second part. The first part is about gold standard reference marks. The training data must be highly reliable. So it couldn't be single marking data because human data could be erroneous, unreliable as well. So what Cambridge do is we have a multi-marking data set. So we have multiple markers to mark on the same responses. And then we do a multifaceted rational analysis to compute a fair average score to generate the gold standard human marking score. We call the reference scores. So these fair edge scores actually adjust for individual severity and leniency, and then also cancel out inconsistencies in human marking. And also we look at those aberrant markers of these exams are too lenient, too severe, and we take them out from the marking pool, and then we rerun the facet analysis to make sure that the data that are used to train or evaluate the automarker are perfectly reliable. They are the ground of truth we can rely on to test the system. Okay, the second bit is about accuracy metrics. We're going to talk about later. And the third bullet is about the automarking accuracy across subgroups of candidates. This is about fairness, whether there's any bias across proficiency, bias across L1, gender, etc. And the last one is about a confidence score. And if an automarker can spit out a confidence score indicating low confidence, whether this confidence score is accurate or it's indicative, is there any chance that high confident responses are missed by human marking, so that a wrong automarker score is given to the candidate? The fourth part is about test design. So are the automark test tasks reflective of the community nature of language use? So what we are concerned is that a lot of automarking automark language tests constrain the task design. Just to taking verse as an example, there are a lot of repetition tasks or constraint speaking tasks like reading aloud, repeating a sentence. But many people argue against this way of speaking assessment, because it just narrowed down the speaking construct because of the use of automarking technology. Even though for monologic speaking tasks like TOEFL IBT, linguist skill, they are not assessing conversations at all. So there's some part of construct misrepresentation or underrepresentation in these tests as well, even though they are reputable, well-known assessment. I think Custom Rover recently published a paper like 2022 looking at what construct are being missed by monologic speaking tasks. But luckily, we are working on conversational AI, so likely we will have a better sort of auto-marked speaking test in the future when AI agent can converse with a candidate in a live conversational speaking test, which allow assessment of conversational speech. So this task design is something we need to consider whether auto-marking system actually change the target test construct or not. The fifth bullet is about malpractice detection. I mentioned that this is utterly important. So there's a high chance that when candidates know that the test is being auto-marked, being marked by computer, they may come up with different gaming behaviors. I think Xiaoming Shi, Jonathan Schmidt-Gell, they did a study back in 2016. They're surveying TOEFL IBT practice test takers who are using speech radar to practice their speaking. And those interviews of survey takers, they mentioned that they're probably going to change their test behaviors when they know that the test is going to be marked by computer. They can speak as fast as possible, or they can keep speaking even when their speech is not sensible, etc. So I think the auto marker is expected to pick on these behaviors and penalize these behaviors as well. And this also happens in writing as well. Like some candidates may attempt twice, two different pieces of writing to increase the length of the writing, to sort of try to trick the system, or they may copy and paste. They have a lot of repeated paragraphs to also to extend the length of the article to inflate the auto-mark score. The different weird behaviors that we noticed. So the auto-marking system needs to be sort of sensitive or vigilant to those behaviors, to be able to flag those behaviors. Okay, so these are the things I'll talk about, like off-topic, nonsensical language, prompt copying, impersonator speaker, inclusive of profane language, sensitive words, repeating paragraph, code switching using foreign language. So this needs to be captured separately in addition to rating system. And the sixth bit is about test administration. So actually, having an auto-marked test in place actually have a high requirements for test administration, especially for the speaking test, because I think audio quality has a big impact on auto-marking accuracy. This is the study we did back in 2021. Myself, Edmund Jones, and Evelina, we did a study on the linguist skill auto-marker, and we found that actually the audio quality has an impact on the auto-marking accuracy. So when the two candidates are sitting too close, so two voices are capturing the same audio file, that will have an impact on the auto-marking accuracy. And when there's a lot of background noise in the room, that will have impact on auto-marking accuracy as well. And the microphone setup is important. So in some deprived areas, probably it'll be very challenging for them to set up a appropriate environment to administer an auto-marked test. Okay, now the seventh is about human involvement, and we know that auto-marking system has its limitation weaknesses. So this is the study we did on lingual skill automarker. So the question is how we can use examiner expertise to compensate for these limitations. So as I've shown you in the diagram before, we use a hybrid marking system. But the question, how is the hybrid marking system designed? I think there are different ways to do it. Like in TOEFL IBT speaking test, they're doing double human machine marking. So I think both human examiners and an auto marker, the speech rater, mark both language use and delivery, but topic development is only marked by human. And then they use a composite score to they sort of aggregate the score compositively to report to the candidates. But Cambridge used either and or, so we flag some problematic responses and escalate that to human marking. There are different ways to do hybrid marking, but the question is how good are they as the end results? And the second one is about whether auto marking error can be mitigated by human marking, can be captured by human marking. The third one is about the monitoring process, because from time to time, the test-taking behaviors may change. So the training data you used to train the auto marker may no longer be valid. There's a new malicious behavior coming up. So I think we need to have a quality assurance pipeline in place, like seeding, maybe, for example, 10%, 5% of response to be both human marked and auto marked to make sure that the auto marker does not go wrong. There's no chance that the changing behaviors will have an impact on auto marking accuracy. Okay, and the model change is about when there's an update of the auto marking system version, we should do continuous evaluation and also inform the test users as well. But this is more difficult for large language models because you don't have any control when the OpenAI is sort of upgrading the version. What do you do? The same prompting language may result in different scores, and there's no control of the version change. That'll be a problem as well. And also auto-marking system explainability. I think so far we use feature-based systems so we can explain what construct is being covered by the auto-marking system. But when you use a neural network model or use a large language model, it's very difficult to explain to stakeholders actually how does the auto-marker work, what are some assessment criteria. So I think interpretability would be a big issue for using large language model-based auto-marker. Okay, and I'm gonna go through these three things quickly. This is about the context, the impact. So even though the automark test may have a narrow construct, but they still have some their implications. So for example, if it's a pronunciation-based automarker or automark speaking test, it still has value for speaking practice or pronunciation practice. But if the test user would like to know a candidate's ability to interact with someone or converse with someone, then an automark test may not be appropriate because it's not really assessing interaction or competence. So checking the goodness, the fitness for purpose is really important on judging whether an automark test is appropriate or not. Impact is about how using automark test have a washback on teaching, learning, and whether that would changing test takers' behavior to game with the system, etc. And finally, transparency. I think we really urge test developers to, including ourselves as well, to be transparent about our auto-marker design and also evaluation results as well. And Cambridge has been working diligently on publishing the auto-mark evaluation results at the conferences and academic journals as well to inform test users about our approach to auto marking and how reliable our auto marker is. Okay, for the last bit, I'm going to talk about evaluating auto marker accuracy. So I saw different metrics have been mentioned in the previous talks. So generally, we will have two sets of scores, one from the computer, one from the human. And the human usually is not a single marking score. As I mentioned, it could be multi-market data. It could be average, fair average. Make sure that the human reference score should be reliable, that there will be two sets of scores. There are different ways to do that. One is that you can use correlation. So on the right side is the scatter plot. The correlation has its own problems. High correlation does not mean high agreement. So you can see the correlation here is about 0.97, but all the data points above diagonal line. What does that mean? That means the computer is always more lenient than human. So it's always giving a higher score than human, which is not really ideal, but the correlation just masks this information. And the other problem with the correlation is the range of data has an impact on the correlation coefficient, and coefficient could be affected by outliers. You have a lot of extreme cases on the two end that will help boost the value of correlation. And also correlation is unable to indicate a curvilinear relationship. So we assume that the relationship is linear, but in some cases they are not. The second metric is rate of agreement. We'll hear a lot of percent agreement, like proportion of time when computer and human give exactly the same score. But this rate of agreement has two issues. One is when the score scale is narrow, like 3 points. I saw one talk, Ananda talk, there's like low, medium, high. There's a high chance agreement. So there's a likelihood that the computer and human agree only by chance, because there's not many choices on the score scale. So this is the issue with the rate of agreement. The chance agreement may affect the real accuracy that we would like to know. And the third one about Cohen's kappa, that's quite traditional. I think SpeechRadar, Xiaoming Shi did a lot of study using Cohen's kappa. Actually, we don't really like Cohen's kappa because kappa did take into account the chance agreement, but it's very hard to interpret. You can see the kappa here is very high, 0.81. Again, you can see the computer is always more lenient than a human. So kappa also is concealing information. And also kappa is not interpreted. How high is good? How high is high? We don't know. And then if we know kappa is 0.81, what is the average difference between human score and the automarker score? We don't know that. We just know there's some agreement association. And also kappa can behave counterintuitively. Kappa can be a negative value. If you look up online, kappa can be negative, which does not make any sense, right? Actually, there's a lot of research arguing against using kappa to check human agreement as well. The next one about root mean square error. So this is more straightforward. It just measures average difference between two sets of scores on original score scale. So you can see RMSC is equal to 0.526, means the average difference between human score and automarker score is about 0.5 on a 9-point score scale. It's very interpretive. So every difference is about half a band, right? This is more straightforward. The problem with RMSC is that it just hides information about the variation of the difference or accuracy across score scale. So it's average. It's not really revealing the full details. The next one, the limits of agreement. So it's a more revealing metric. It helps to show the degree of agreement in a meaningful way and show how the differences actually change across the score scale proficiency. So in this scatter plot, you can see the x-axis is the score scale from 0 to 6. On the y-axis is the difference between the automarker score and the human score. So we would expect the data points falling on 0, so there should be no difference. But actually, the mean difference is about 0.36. So it's very close to 0, but not exactly 0. And then you can see the upper limit, so which is in the worst case, like in most of the cases, like a 95% interval, the difference about between computer and human about 0.98. But in some cases, it could be minus 1.71. It shows the range, and you can see the data points across the score scale. And then the automarker tends to be more lenient in the lower score scale than in the higher score scale. And the computer, you can see, tends to become negative, which means computer give a higher score around C1, C2 here. So which means at the higher end of the score scale, the human is more lenient than a computer. So this is very revealing all the details of the automarker performance. It's very helpful, informative for stakeholders to know. The last one is about Earth mover's distance. This is about checking it's a measure about the difference between two sets of score distributions. It's a metric, and it's about, for example, on the right side, you can see two score distributions. They have the same shape, but different mean. right? You can see the right pie of the score distribution is moving to the right. So this is a shift of the distribution to the right. And in the lower two figures, you can see it's the same mean, but it's a different shape of the score distribution. The distribution become flatter. So what does Earth moving distance do? You can see EMD is for distribution shift is 3.4 for both the upper two pictures and the lower two pictures. So there are two ways to change the score distribution. One is to change the mean, the other one is to change the shape. So this metric actually can help measure the difference between the automarker score distribution versus human score distribution. It could be changing a mean or changing the shape. So 0 EMD equals to 0 means there's purely overlapping. So there's no difference at all. The larger EMD is, the more different the two score distribution is. So it's a useful metric to tell whether using automarking will change the score distribution in candidates population, which is really helpful to know. All right, so I think I'm running out of time. I'm going to quickly summarize what I talked about. So training data should be representative. They should have a broad spectrum of scoring features to cover the construct. The scoring algorithms should be explainable, but large language model is not. And there should be evidence about score accuracy, fairness, reliability against aberrant response behaviors. And also should be compliance with test administration requirements. The audio quality is important. And we need to apply hybrid marking to mitigate automark errors. We don't really recommend purely using automarking in high-stakes assessment context. We know the limitation of automarking, and the impact on learning and the teaching should be positive. And transparency is important for stakeholders to understand how automarker works and decide whether the automarker language test is appropriate for particular testing purposes. So these are all the guidelines I think we suggest the users or developers of automarking system to follow. And please see details for our white papers. And here are the references. And these are the last paper here is the white paper. You can Google the presentation topic, and that will pop up in the first top results. All right, thank you all.
Thank you so much, Jing, for a very insightful presentation.